Hey guys, I'd like to welcome each and every one of us to our discussion for today. So today we're going to look at one of the aspects of Newton's contributions towards describing the concept of motion. And of course, in this case, we are going to look at various aspects of Newton or the Newtonian laws of motion. Now, in our discussion for today, I'm going to basically be biased on the first law of motion. But in our subsequent videos, we're going to look at the two other forms of Newtonian's laws of motion, which are, of course, are going to assist us in trying to explain the changes in state of motion of objects, which are either going to be at rest or are in the process of motion. Now, in this case, we're going to use the concept of one dimension, which is going to be, of course, assisting us to develop this specific idea of the Newtonian laws of motion. And of course, they're going to assist us in explaining the subsequent laws, which we are going to look at in a short while. So in this case, we are going to have this specific representation for a vector, whereby we're going to have this represented in terms of a v. So I'm going to consider this specific vector with another vector, which can be given in terms of this particular representation. So the first vector is going to be given as a quantity given in terms of magnitude and direction given as such. So perhaps we can consider giving the direction of this specific vector given as such. So if you consider that one, we can look as well at this specific coordinate system and try to represent another vector which we can give in terms of a v. So in this case, we are going to have both the y component and the z, y and x component in this describing this specific vector given in terms of a v. So in this case, we shall have this one given in terms of a vector. V is equivalent to vx plus the v y component given as that. So in this case, the description of this specific vector is going to take account of the two specific coordinates for the x and y. And lastly, we can have another vector given in terms of this particular representation, whereby we're going to have the x, y, and z components. So in the three scenarios, basically I'm going to use the Cartesian coordinate system in trying to describe this specific aspect of vector. So we are going to have this vector as well for v represented as the v component in the x direction plus a v component in the y direction plus of course, a v component in the z direction given as that one. And the three are going to form a set of representation for vectors in one dimension given as that one. So in this case, we shall have this first one given as a representation of a vector v in one dimension. And then we shall have a representation of a vector v in two dimensions. And lastly, we shall have a representation of vectors in a three dimension given as that one. So in this case, we are going to consider this specific aspect of vector representation. And the Newtonian's first law is going to emphasize on a representation of particularly the changes in the state of an object which are going to be considered in either in motion or at rest for one dimension. And in this case, of course, we're going to see that this is going to be assisting us in trying to describe an object in terms of its dimension, as we have said. And then, of course, we are going also to look at, so this basically is going to imply the concept of a direction. So in the case where I'm going to mention an object that is going to move along the x component, the y component, the three components for x, y, and z in this specific case, then therefore that's going to represent a vector in 1, 2, or 3 dimension. So for the Newtonian's first law, then we're going to create an emphasis in this. And this is going to assist us describe the nature of the force involved, the concept of acceleration, and perhaps this aspect of velocity, which we have mentioned in our previous videos. And of course, we're going to consider the relationship which is going to be developed from this specific aspect. Now, Newton, of course, have formulated the above laws which I've mentioned in order to describe the nature of these forces which are going to be involved in this particular case. And of course, there are a specific effect which they're going to cause in either the motion of objects or the effect which they're going to be causing on objects which are at rest. And this is going to be applicable for both the large or the macroscopic objects and the microscopic objects in that specific case. In some of our videos, we have done the concept of a quantum mechanics, whereby we have exclusively looked at the concept of elementary particles, and of course we have borrowed heavily from the Newtonian's laws of motion, or the classical mechanic aspect, which has assisted and tried to describe the motion of subatomic particles. In this case, I'm going to consider an object being placed at this specific point. So I'm going to assume that, as I've explained, of course, we're going to consider this specific object lying along the x-axis, which is a one-dimensional aspect that I've mentioned. So if a particular force is applied on this specific object along this x-axis in that particular direction, we're going to see that this specific case we shall have this object moving from the point of rest, given as that one, and this object is going to be in a state of motion, given as that. So we shall have this one perhaps given as that one to depict that the object is just in a point of motion. We can describe the velocity component of this particular object that is at rest given in terms of 0. Since it's going to be at rest, therefore it's going to possess a velocity component of 0, and its a particular acceleration is going to be 0. So upon application of a force, this particular of course object is going to assume a state of motion, whereby we shall have its velocity component given in terms of a 0, which is going to be the initial. So perhaps I can just give this one in terms of so 0 is going to be the magnitude of the velocity at rest, but while in motion we're going to have, so we shall have this one given in terms of v is equivalent to 0, and we shall have acceleration given in terms of acceleration along the x-axis, which is going to be 0. But in this case, upon motion, we're going to see that we're going to have a specific quantity of this acceleration given in terms of the initial one plus the final one, which is going to be describing the velocity component and acceleration of this specific particle in that particular sense. So we shall be looking at the effect of this specific force, which we have mentioned in this particular case, which are going to constitute Newton's law of motion. So in a summary form, we can state this specific law of motion for Newton's laws of motion in terms of perhaps a statement, a summary, whereby we're going to see that a body or an object, will continue to be in its state of rest or motion. In its state of rest or motion with a constant velocity. So in this case, when I'm talking about this state of rest or motion with a constant velocity, this aspect of a constant velocity is going to be, of course, implying the aspect of this state of motion. So it's either going to maintain its state of rest at this specific point for a description of velocity and acceleration given as such, or be in motion with a constant velocity given in terms of this specific representation, whereby we're going to consider the two as a constant. So from this particular statement, a body or an object will continue to be in a state of rest or motion with a constant velocity unless interfered with by an external force given as that one. So this is going to give a summary of basically the Newtonian's first law of motion, which states that a body or an object will continue to be in its state of rest or motion with a constant velocity unless interfered with by an external force. And this is going to form Newton's first law of motion, which we're going to come across in our various discussion of objects and the concept of motion, especially in classical mechanics. Now, this is going to assist us to try to, of course, explain the changes in state of motion, as I said, of various objects, which are at rest or in motion. So check our description boxes for various links of other videos which we are going to do. Subscribe and engage us in the comment section, and also ring that notification bell to be getting various updates on our uploads we do in mathematics and sciences. So we'll stop there for now. Check us in our next video, and of course, as I said, check our description boxes for other links for the similar discussion. So that is it for now, guys. Bye. God bless you. Catch us in our next video.